Hello, and welcome to this demonstration video for the M3 Field of View software package. In this video, I will describe and demonstrate the four main elements of the M3 Field of View software: the custom DXF crosshair, overlay feature creation, importing DXF overlays, and finally pattern recognition. If you're going to be following along on a system of your own, please confirm that the Field of View option is enabled for your M3 system. This can be determined by checking the Probe menu for the presence of the DXF Probe button. In addition, the following examples are intended for use by individuals with some basic understanding of M3 software operation. The first feature I will discuss is the addition of a custom DXF crosshair. This new crosshair type can be translated, rotated, and can be used for manually probing features within the field of view. In addition, a custom DXF crosshair file can be created and used in place of the default crosshair design. The system will use by default a solid, simple crosshair. However, any new custom DXF crosshair can be used by simply placing a crosshair DXF file in the MetLogic settings directory. This DXF crosshair file requires that a datum 0 position be established within the DXF file itself in order to accurately enter points in the M3 software. To translate and rotate the DXF crosshair, use the Pan Rotate toggle button found in the top left corner of the M3 Live video window. Note that the Live DRO is updating according to the location and orientation of the crosshair within the field of view. To change the color of the DXF crosshair, simply press the Color toggle button found below the Pan Rotate toggle button. In addition, feature measurements can be performed using the DXF crosshair. As is the case with the standard M3 fixed crosshair, simply select the feature you would like to measure, position your crosshair on the edge you would like to probe a point on, and press the Enter button to enter that point. When probing is complete, press Done to complete the measurement. The feature is added to both the feature list and part view. Press and hold the Pan Rotate button to recenter and to zero the cue for your custom crosshair. The next FOV feature we will discuss is the ability to create features in the M3 software, specifically for use as an overlay. With this, a visual band for acceptable deviation can be defined and will be generated along with the created overlay feature. This allows created overlay features to be used for quick and simple determination of pass or fail conditions, or simply for determining unacceptable deviations from nominal form. The process of creating features for overlay utilizes the existing Create Feature mechanism found in the M3 software. Press the Create Feature button for the desired overlay feature type. For our example here, we will create a simple 5 mm line overlay that includes a 100 micron tolerance band. We select Measure Line, then Create Line to display the Create Overlay line screen. I will now enter the desired 5 mm length, define the feature type as overlay, and finally define a tolerance zone of 100 microns. Now press Done to complete the line feature overlay. You can see that the line overlay can be manipulated. Pan, rotate, or change the color of your newly created line overlay feature. As with the DXF crosshair, press and hold the Pan Rotate button until the created overlay returns to its original position. A circle overlay feature can quickly be created using the same process we just performed. Note that the circle overlay we just created replaced the existing line overlay. Only one created overlay feature can be displayed at one time. The next piece of FOV functionality we will discuss is the Import DXF overlay capability. This DXF import system allows for the display of existing DXF files as an overlay for the live video image in the M3 software. These overlay images can be manipulated in a very similar manner as the DXF crosshair and the created overlay features we've just discussed. The translate, rotate, and color change functions are all available through the same user interface mechanism as we have just discussed in the previous two sections. In addition to panning, rotating, and changing the DXF color, DXF files that are imported in this manner can also be displayed with error whiskers for the portion of the live video image that does not fall within the acceptable zone. This acceptable tolerance zone and the dark light layer assignments are defined within the original DXF file itself. The display of error whiskers can also be toggled on and off using the Display Profile button found in the top left corner of the live video window. DXF files can be imported into the M3 software in one of two modes: UCS mode or screen mode. I will explain these modes as I demonstrate each one of them for you now. When the string UCS is added to the file name of a DXF file, the file imports in UCS or part mode. Part DXF imports will be imported to a datum and alignment if one has been established within the DXF file itself. As you can see, the overlay remains fixed to the part features themselves. As is the case for all of the DXF tools, the pan, rotate, and color toggle may be used to manipulate this part DXF. Toggling the Active Profile button, found in the top left corner of the screen, will show or hide the current error whiskers for the overlay. When the edges of the part all fall within the bounds of the overlay, the selected color will display for both the inner and outer bounds of the DXF, indicating an acceptable fit. When a DXF file is imported without the UCS string in the file name, it is displayed in screen mode. DXF files imported in screen mode are not displayed relative to the established part datums. As you can see, the overlay does not travel with the part and remains fixed in screen or pixel space. As with the UCS import, the overlay can be displayed with or without active error whisker display, and can be pan, rotated, and have the color changed. The fourth and final FOV feature to be discussed is pattern recognition. The pattern recognition feature allows for the capture and subsequent detection of selected image samples and can aid in the establishment of part reference locations from non-traditional part geometries or image characteristics. The following example will demonstrate the capture of a pattern and the detection of that pattern in program playback for the purpose of generating part reference. Select the pattern probe from the Datum submenu. Using the Marquee Selection tool, identify the pattern that will be used for playback detection. You will see that the pattern feature is added to the feature list in Part View, as is any other feature in the M3 software. In this example, we will align and zero on the selected pattern feature, and then measure some additional features around the current field of view. We now play the part back. As you can see, our captured pattern feature is detected and tracked by the M3 system. This is what will allow for non-fixtured parts to be measured quickly and accurately. Also note that the collected pattern features images can be viewed from within the feature detail itself. This completes this overlay. Thank you for taking the time to learn about the features offered within the new M3 Field of View package.